Hi folks, Professor Jakovich here, and now we're going to compute the present value of two types of annuity, an ordinary annuity and an annuity due. And you can see that with an ordinary annuity, the payments occur at the end of the period, as shown here in a Fourier format, and the same for a year annuity. If it were an annuity due, the payments would occur at the beginning of the period. So let's work some actual problems, both for an annuity and an annuity due. So you just retired yesterday and you want to double check that your savings are enough to hold you until your expected arrival in heaven, hopefully heaven, in 25 years. You intend to live on $72,000 every year, taking a lump sum of that $72,000 at the end of each year. How much should you have in your savings right now, today, the day you retired, if it's earning 5% annual percentage rate? Well, let's fill out our table and see. So the present value is what? That's what we're trying to solve for. The present value of an annuity. We're going to take an equal amount out every year along a timeline. So right now we don't know what our present value is. So we put a question mark there. The future value, if you think about it, it doesn't say anything here about wanting to leave money for anybody. We want to just know how much do we need to save that we can retire and have enough till we croak in 25 years. So our future value is zero because we will have spent it down to nothing. If you want to leave 10,000 for a nephew, you could put 10,000 as the future value, but in general, zero. The rate is, we said, it's earning 5% per year, so we put 5% there. The number of periods, we said, is 25 years. And this is an annuity, and it's going to be an ordinary annuity. Our payment is $72,000, and it's negative because we're taking the money out of the annuity. Type will be zero for an ordinary annuity. We now have everything we need to solve this problem. So just like in all the other examples, we're going to put what we want to solve for, which is present value, in this format, equals, and then what we want to solve for, PV, open parenthesis, and Excel tells us what order to put in the variables. So first is rate. I'm just going to click on it. 5%, type a comma. Number of periods is next. Click on number of periods, enter your comma, click on payment, enter your comma, click on future value, which is zero, enter a comma, and then type and close parentheses. Okay. For him to have saved enough that he can take out $72,000 every year for 25 years, he needs to have saved up $1,014,764.01. Not bad. Now, what if it the same problem, but it's an annuity due? So he retired yesterday, but he's taking his first payment today because he's broke, which is actually likely that you'll take your first retirement payment right away. So here we go. It's going to be the same. So I'm going to, oops, that didn't work. We'll just start. So equals PV, open parenthesis, and it's going to be all the same stuff. The rate, 5%. The number of periods, 25. The payment, negative 72,000. The future value, 0. But then we get to type. And I didn't put all this under annuity due, but the only thing that would change is type will now be 1. There'll be a 1 in this last. I'm just going to put 1 for the last. And look what happens. If he takes the money out right now, he actually would have to save more to make sure he doesn't run out before he dies. And it's a hefty chunk of change, the difference. If you look at that, it's about $50,000 difference? Yeah, $50,738 just because he couldn't wait 1 year to take his first 72,000. So since he took out 72K immediately, that made a $50,000 difference in how much he needs in that big old bucket that he has to live off of. Okay, so there you go, present value of an annuity and an annuity due.